thank you for joining us here today, everybody, for Gilson's presentation of the fundamentals of hazardous area classifications. For us to get started, I suppose I should probably introduce myself. So my name is Joe Ryan. I'm the VP of Sales and Marketing at Precision Digital, and I've been marketing, selling, designing hazardous area instrumentation for about 15 years with them now. And so I've had a lot of exposure to that, probably not as much as some of you here in the audience today, but a fair amount. And as I actually was an engineer designing some of these products, I also have a unique view of the agencies themselves. And so hopefully, I think all of you will learn something here today that'll prove useful in your jobs that most likely involve this kind of equipment. So what we're going to do here today is we're going to talk about why we classify hazardous area equipment. Obviously, we want to prevent explosions and keep everyone safe, but there's a little bit more to it than that. Talk about the definition of what a hazardous location is, and then start diving into some of the terms that many of you have heard before, like what is a classification like a div, a class, an area, maybe a zone. What do those things mean? Then we're going to talk about the different types of protection methods. You've probably heard those terms thrown around like explosion proof or intrinsically safe or non-incendive. Well, what does that mean and how does it relate to your products and how you're trying to connect these up? And then we're going to end with an actual look at a sample label you'd see on a hazardous area product and really try to dive in all that alphabet soup that's on there so you can understand what all that means. We'll also take a look at a few real world examples of hazardous area products and show you how you might choose between one or the other or determine which kind of technology is right for you. So what do you hope to take away from this by the time we're done? Well, I hope you've learned the basics of why and how hazardous areas are labeled and classified. Not just that they are, but really the reasons behind it. I think that's always important to remember when you're talking about something that's safety related. I hope you've learned how to break down that alphabet soup of labels, markings, symbols, agencies, and regulations that you see when you pick up a hazardous area product and you see that perhaps metal nameplate on the side of it. And I hope you can put it all together and get some real world examples that might prove helpful to you about what you might want to choose for hazardous area agencies or technologies for your next project. So let's start with why classify an area as hazardous, right? The most obvious one is you want to eliminate the potential for an explosion. There are lots of reasons why explosions can happen. These agencies have decades of experience figuring those out, working with industry to make sure that these approvals account for essentially any kind of hazard you might find in a plant. But beyond just the plant, we also want to promote the safety of people. You know, really that's the #1 reason you're doing this is because you want to make sure the equipment in your plant is properly approved so that your personnel are safe. Now, I'll grant you, agencies like FM are in reality insurance agencies, and so you might think it's property damage, but people are a company's biggest asset. They're the largest liability for the insurance companies, and realistically, morally, it's just the right thing to do, to use the right equipment, get it installed properly, and make sure you're following all the regulations and guidelines. So property damage is important, but really the #1 thing is the safety of your plant personnel. So what is an explosion? You know, what actually causes something to happen? Well, as we go through the presentation, it's good to keep in mind that to have an explosion, you've got to have an ignition source, meaning something that's actually providing that heat or that power to ignite the atmosphere. You've got to have an oxidizer. Usually that's just the oxygen in the air. That's your fuel name, so to speak. And then you've got to have a flammable substance, something that's actually going to ignite. You know, that's your actual hazardous material. And the reason it's good to keep these in mind is because as we go through this, you're going to see there's different types of protection technologies, different protection methods that all protect by going after parts of this 3-part equation that causes an explosion to happen. Where might you run into hazardous areas? Well, you might see them, of course, in, say, an oil refinery, but beyond that, you might see them in paint shops. You might see them in corn or flour mills, anywhere where you have potentially explosive dusts floating around. Chemical plants have plenty of hazardous areas in them. Liquid transfer terminals who are working with those hazardous materials. Really, anywhere where you have tanks that are holding anything other than water, you probably have some form of hazardous material going in through there. Even at places, say an asphalt shop might have hazardous areas because they have a tank that contains their own fuel supply. So lots of facilities have these. Chances are yours does. Hopefully you know what they are, and if you're not quite sure, there's probably someone there you can ask just to be familiar with what the areas are that you need to keep an eye out for these kind of equipment and behave properly around. So there's three main ways you're going to prevent an explosion. There's of course a lot of protection methods, but these are the ones you're going to see most commonly. So the first thing you can do is you can contain the explosion, so that if there is a spark, for example, from electronics, if there is a flammable gas present or other material, you're going to hold that explosion contained from getting out to the other areas of the plant, out into the just general atmosphere. And that's where you see explosion-proof devices. That's what that explosion-proof device is meant to do. These big metal boxes that explosion-proof devices are designed inside of are not to protect the electronics from the explosion, which is a mistake a lot of people will make. It's designed so that if there is an explosion inside of the housing, it contains all that energy. It doesn't let that flame escape and ignite all of the gas that might be in the area. Then you've got the ability to remove the spark or other potential source of ignition, so that even if there are hazardous materials present, you can't actually cause an explosion because there's not enough energy to ignite that atmosphere. And so that's when you're going to see non-incendive or intrinsically safe designs. They go right in the hazardous gas, for example, or right into the dust cloud. However, they don't have enough power, if installed and operated correctly, to actually ignite that area. Then you've got isolation of the explosive substance from ignition sources. And that's where you see purged panels. You're going to say, well, inside of this box, perhaps you have electronics that, if something were to go wrong, could actually cause a spark or cause ignition. And so you're going to purge the area so that there's no possibility of that hazardous material getting inside the box. So for example, in this case, you have pressurized inside the box, and you're going to keep that hazardous gas out by pumping in something more inert. So that's how you use, that's the purpose of explosion-proof devices, IS or non-incendive designs versus purge devices. They all really attack a different element in that equation of what causes an explosion. Now, where do all these guidelines come from that we're going to be talking about? Well, they're a mix of places, really. You've got OSHA that has some guidelines. You've got the National Electric Code, Canadian Electric Code, the NFPA. You've got insurance requirements. You've got documents at some facilities, especially larger companies that have their own regulations on how to control these and what kind of marks are acceptable. So the actual testing standards are really made up of a wide range of sources, all depending on what mark, what country, and what protection method you have. Here in North America, what are you most likely to see? Well, you're most likely to see these marks. That would be Factory Mutual, or FM, Underwriters Laboratories, or UL, or the Canadian Standards Association, CSA. There are others. However, these are the most common. FM is actually a private insurance organization. They started in the insurance business, and they started putting their mark on things because obviously if you're going to insure somewhere that has a hazardous area, you want to make sure that it's safe. And so that's how the FM mark came to be. It's very popular in the United States. You don't really see it too much outside of there. And if you're going to get a product FM approved, they're going to be the ones who actually do the testing. So anything you see with that FM mark, and there are variant versions of these. This particular one is for both Canada and the United States. And it assumes that there's a lot of room on whatever we're putting this mark on. So you may see products that don't have that approved written on them. You may see products that are only approved for the US or Canada, where you may see either none or both of these little C's or US's. Those are just different variants of FM approval. Underwriters Laboratory, another very common one in the United States. They're a private standards testing organization. They now have deals with CSA, so they're becoming more popular with Canada as an alternative to CSA. They also do all their own testing. And so if you were going to have a product with a UL mark on it, something like this listed mark here, which again is the fully populated version. This is a listed product with both Canadian and US approvals. They're going to be the ones who do that test. And they can get that Canadian approval, which tests it to all the same Canadian standards as CSA would. UL does have another looking mark that they're trying to promote right now that looks more like that. It's just another variant of the mark. And then you've got the Canadian Standards Association, or CSA. That is a government-driven organization up in Canada. They have agreements with UL. They test the same standards, so they do have a mark that has a US on there. Most of the time you'll see CSA, it's just going to have the CSA logo on it, which means it's just tested to the Canadian standards, but they can do US as well. And they actually fairly recently purchased CIRA, which is a European organization, so they can really get out there and have a more global outreach, getting other marks as well. So sometimes when you do see CSA, you're seeing things like ATEX and such more common, which are popular in Europe. But those are the ones you're most likely going to see here in the United States. Now, you may also have products that are listed with international approvals. Mostly these are based out of Europe. And the two most popular you're going to find there are ATEX and IEC, both of which have their European names, which I'm not even going to begin to try to pronounce. So ATEX is really strong in the European Union, although it does make it to worldwide countries. Unlike most of the US standards, it's a harmonized standard that is not tied to a specific testing agency. So the European Union publishes this set of standards and then approves notified bodies to do the testing. So you've got different countries that have different companies that all compete for putting the same mark on the product. It's not like UL, where if you want UL, you send it to UL and they test it. If you want ATEX, then all you do is send it to one of these notified bodies and they test it for ATEX approvals. IEC is essentially very similar, popular in European Union as well as some other countries like Australia. It's really a competitor to ATEX. Testing is also done by notified bodies. And so what do ATEX and IEC mean to US companies? Well, it's going to depend on your company. It's going to depend on where you get your insurance. It's going to depend on the standards that you follow specifically. Are ATEX and IEC appropriate for your facility? That's a decision that unfortunately your facility is going to have to make, with input, of course, from local standards and insurance companies and general company policy. So a lot goes into a hazardous area rating. You've got area classifications. I'm sure you've all heard the terms like Class 1, Class 2, and then you've got div zones, right? So you've got like Class 1, div 2. Sometimes you might hear about zones, a popular thing in Europe that's sort of moving to the United States, but mostly we're all about divisions here. Then you've got equipment groups and temperature classes, various protection concepts like explosion proof, intrinsically safe, non-incendive, and you've got Nema and IP codes. And so I really want to talk about each one of these and give you a sense of what they all stand for and what their purpose is in the hazardous area approval. So let's talk about class definitions first. You've got three basic classes of equipment. Class 1 is for areas where flammable vapors or gases are present. So anywhere you've got a flammable gas, you're talking about a Class 1 area. Popular places you may see that are oil refineries, paint shops, offshore oil rigs, anything where you've got materials that produce a flammable vapor or gas. That compares to Class 2, which is all about dusts. So now we're talking about coal mining, grain silos, hay storage, plenty of otherwise sort of inert materials when you put them in the air as a cloud of dust become flammable. And so anywhere we've got that going on, you're talking about a Class 2 environment. And then Class 3 is for areas where you've got ignitable fibers or small pieces of material that may be in the area that can become flammable. So you're talking paper mills, textile mills, woodworking facilities, in places where you may have small bits, not quite dusts, but like fibers that can either form layers on material or be present in the air that could combust. And the reason you have all these different classes is because equipment gets classified to these different environments. One piece of equipment that's good in a class 2 area that protects against dust igniting may not be appropriately sealed or protected to prevent a flammable vapor or gas from causing a problem. So you've got to know the classification of your area to make sure that your equipment and your installations all are approved to the appropriate class. Classifications describe the frequency or of the presence of combustible gases and dust within a hazardous area as well. And this is where we get into divisions and zones. Most of you here are probably familiar with divisions. Divisions are what's been used in the United States for years. Zones are something you see mostly in Europe. You'll see zones a lot of the time on ATEX or IEC product. But if you've got an FM or UL product, then you're going to be talking about divisions most likely. And so you've got division 1, which means your hazardous or ignitable substance is expected to be present for long periods of time. You just know, because of the nature of the work you're doing, that the materials you're working with are going to produce, or maybe you're working directly with, hazardous gases and vapors. That's in contrast to division 2, which means you're only going to have those present in abnormal conditions. So for example, division 2, you see a picture there of a gas station. Well, under normal circumstances, there's not a large amount of gas vapor moving around this facility. Maybe you've got some right at the spout, but usually there's not just clouds of it floating around the gas plant. Whereas if you're in a manufacturing facility, if you're within so many feet of a opening into the top of a tank, well, you know that just during regular operation, you could have somebody open this hatch and vapor's going to come out and it could be potentially hazardous. So division 2 does require quite a stringent safety mechanisms as division 1, because division 1, you're assuming that something is going to be there. Division 2, you're saying something is only going to be there if something's sort of already gone wrong. Now zones, those are a newer classification method, really started in the 90s. Again, you don't see it a lot in North America, but it is becoming more popular. And when it does show up here, it's based on international standards. So here I've got a useful slide that crosses over those divisions and zones for you if you do find that you run into zones a lot. So here in these tables, what we describe for you is the flammable material code. If it's present continuously, in other words, it's just always there, or intermittently, but under normal circumstances. You'll notice that both of those are division 1. So we're saying in this case as well, let's say I have a hatch on a tank. Opening that hatch is going to be something that I know is going to happen. But if the hatch is closed, then I don't have any gas present. If the hatch is open, I do. Well, that would be an intermittent present material. It's sometimes there, sometimes not, but I know that it's going to happen, and when it happens, everything's okay. Then you've got present abnormally, which means, well, I'm only going to have gas next to this particular area of the tank in the case where there's a leak, or my air handling system isn't working properly, or something else has happened that's causing it to go wrong. And that's your division 2, and that's your zone 2. The zone system just breaks it down between zone 0 and zone 1 to make a differentiation between present continuously and present intermittently. The zone system also addresses gases versus dusts. And so when you're talking combustible dusts, you're talking about zone 2s versus gases where you're talking about single digit zones. So you've got zones 0, 1, and 2 versus 20, 21, and 22. So I know we're going to be sharing the slides up after the presentation. This might be something for those of you who deal with zones and are trying to understand the differences to take a look at post-presentation. So before we dive more into the details of hazardous area approvals and things that some people may not be too familiar with, I thought we'd pause for a minute and see if there's any questions from the audience.
We do have one so far. It states we have a manufacturer with a product that has Class 1 Div 1 rating from CSA, but not yet from FM, although it was submitted. Does FM and CSA have to test to the same standards for Class 1 Div 1?
Unfortunately, they really don't. Now, those standards will be very close, but they are not exactly the same. So for the manufacturer of that product that has CSA on to get FM, FM's probably going to want to do a slightly different suite of tests than what the CSA mark would require. And that's why it takes manufacturers time and money to be able to put multiple marks on their products. To give you a real world example from my experience at Precision Digital, we have products that have FM approval and we have products that have UL approval. UL and FM do different testing on the labels, something most people might not even think about. What kinds of chemicals are your labels going to be exposed to, and will they adhere? Will they keep the markings on them? Are they going to get damaged so that somebody can't read the serial number later? Some may think it's a minor difference, but as a result, you have a lot of work that goes into testing it one way versus the other. And in the end, they're both just going to give you a US hazardous area approval because the standards are slightly different. Now, if that were UL and CSA, it might be a little different, but because they have agreements with each other. But as you're talking FM and CSA, they will be similar standards. They will not be identical. But hopefully, if you need FM, hopefully they get you FM. Now, is CSA acceptable in that facility? It's going to be a call to be made by that facility with a lot of input from others.
We actually do have one more. States purge panels. I will be interested on how to address panel-mounted devices such as precision digital meters. It seems to be a practice that as long it is NEMA 4 front, it is acceptable, but I feel like there needs to be more clarification on this. Sure,
and you're right. Just something being NEMA 4 is not going to be sufficient for it to get used in a panel. A purged panel is going to have pressures inside of it, and NEMA doesn't really address that. The NEMA ratings, as we'll see later, really have to do with ingress protection. In other words, can water get in here? Can dust get in here? It does not test for can gases get into that panel. It does not test for whether or not the product itself, for example, the Precision Digital panel meter, can withstand the internal pressures that are pushing out, or could that potentially cause a break in a faceplate or some such. Now, that having been said, Precision Digital panel meters are used in purged panels all the time, but because there's not a purged panel meter approval for them, that purged panel needs to get looked at by the appropriately marking agency in order to give it approvals. And then they'll usually either issue an approval for the entire design just to be made in the perpetuity. They'll issue an approval for a certain number of those designs to be built in a specific way, or they'll issue an approval for this one particular unit, all depending on what the person building the purge panel is looking for. So my advice there would be, you're right, that NEMA 4 is just not enough to assume that, well, I'm going to put this in here, therefore I'm still keeping my hazardous area approvals. The agency is going to have to be involved, and they're going to have to give it their stamp of approval in order to move forward. And with that, then, if we can certainly keep the questions coming in, and I'll just move forward, and we'll dive a little bit more into some of the other types of information you might see related to hazardous area approvals. Oh, pardon me. Groups is something that often appears on these labels and gets talked about. And so you understand, the group isn't about the product itself, but more about the environment it's going to be in. So taking a look here at the traditional and US and Canada groups, it has to do with the materials that are going to be exposed to it, right? So as you see here, you've got a listing of various hazardous chemicals. These are easily recognizable as hazardous, explosive, flammable materials. But when you're trying to approve a product, all of these different materials ignite with different forces or at different temperatures, and they have different characteristics. So you need to know what group your product is approved for, or multiple groups your product is approved for, to work with your particular environment. A device that has group D approvals for propane is not going to be appropriate in an environment where you're dealing with ethylene. And so oftentimes you will see products that are labeled, for example, for group B, C, and D, letting you know that they've got all of these covered. Another important note here is that these are different than Mine Safety and Health Administration approvals. There are approvals that are sometimes required, depending on the equipment, to work inside of mines. This is not that. So you may certainly be able to be used in a mining facility, but there's a separate set of approvals, and if you're in mining, you're familiar with those. That's not what we're referring to here. This is just what is the material that's going to be present. Now, if you're talking international standard, then you've got some slightly different groups, but the concept is the same, that your group is going to want to match up to the material that you have that's hazardous. Temperature class is something that you'll see on these hazardous area approved pieces of equipment. That's a little different than operating temperature range, and so it's worth taking a moment just to cover what that means. Your temperature class is the maximum ambient surface temperature the device can reach. So in other words, it's saying that the outside surface of this device can reach this temperature without igniting the atmosphere. And so you can see how that might tie into what the material is that it's being exposed to, because different materials will have different ignition temperatures. It also takes into account things like what the surface temperature is under dust layers. If you've got flammable dust, let's say you're working in a sugar mill, well, it's important to know that, well, hey, if I have a foot of dust on top of this thing, that's a problem. And so there'll usually be an approval that will cover up to a certain amount of dust. It will say, well, look, you can have an inch of dust on this and you're still okay. But the agency is going to give that temperature class, assuming that you're going to be under that layer of hazardous material. Once they determine the temperature class, then they can test things like the electronics inside to find out what the ambient temperature can be in order to prevent some kind of ignition. And this is a great example of why you can't just put electronics inside explosion-proof enclosures and call it an approved product or call it a fully approved system. So that's an important concept. So let me just pause there and say it one more time for you. You cannot take an explosion-proof enclosure, like the ones you see here in the bottom right, put electronics in them and call it a fully approved product just because the enclosure itself is. Products like Precision Digital's Protex Max are a fully approved product. We've sent this out to be tested by the agencies with all of the electronics in them at full power to see what happens with the temperatures. If you just put a panel meter inside of some kind of a mount and you stick it inside of an empty box, that is not a fully approved product, even though it's going in an enclosure that has agency approvals, because no one has checked things like, for example, how hot that product's going to get, how hot it's going to get under a dust layer. Is it going to get so hot it causes you a problem? Other things go into that determination, like how much space is available inside of the enclosure for hazardous gases to build up. So just be aware, if you are just putting power supplies inside of boxes, things like that, that's great. You have a hazardous area approved box with a power supply in it. You do not have a hazardous area approved power supply. That should still get looked at by someone from your approving agency. Some inspector should take a look at that system and give it their approval. The alternative is you go out and you get something like that Protex Max you see there that has power supplies integrated into it and is a fully approved product. Protection concepts are things like explosion proof, non-incendive, intrinsically safe, purging. That's the method that you are using to prevent the explosion. And so the method, for example, might be no arcs, sparks, or hot surfaces. That's going to get you an approval for increased safety or non-incendive. You can contain the explosion and extinguish the flame before it has a chance to spread outside and cause more harm. Well, that's your explosion proof, or if you're looking at European approvals, for example, you might see flame proof, some other ones like powder filled. You can limit the energy of spaces and surface temps. What that means is something that is intrinsically safe. And how does an intrinsically safe product work? Well, it's saying if you install this appropriately with the needed barriers, etc., you don't have enough power in that device to ignite anything. I'm sure we've all seen an intrinsically safe product in a plastic housing versus an explosion-proof product in a big, beefy housing. Well, the difference there is the explosion-proof product is going to contain the explosion, whereas a intrinsically safe product is going to say, look, I can't actually cause any ignitions to begin with. And then you've got keeping flammable materials out of the area altogether. And that's where you get your pressurized or your purged panels, as well as some other options there as well. And so it's important when you're using this equipment, you know the protection method, because it's going to determine how you install it. So we've got, for example, this picture on the right, and you can look at these Protex Max units, and you can just tell that they're explosion proof. They're in a large aluminum housing. It's a solid unit, probably weighs about 17 pounds. And it's a Nema 4X housing. It's got a fully approved product approval on it for FM, CSA, ATEX, and ICEX. And now that we know all that information, it tells you how you have to install it. So for example, you'll notice that they have approved plug installations everywhere where we're not using one of the conduit openings. And then you've got epoxy filled, excuse me, I'm blanking on the word there for a minute, but you've got epoxy filled stops essentially in line with that. Thank you, epoxy filled seals here, so that you can prevent the explosion from traveling down these lines. If this were a intrinsically safe installation, well, I wouldn't need that. However, I may need to, for example, have barriers on all of my signals in and out, versus a non-incendive installation where I may not need the barriers because it's going to have different divisions that it's rated for. So knowing that protection method lets you know how you have to install these. Now, even in an installation like this, if I'm going from an explosion-proof device down these wires to somewhere with, say, an intrinsically safe transmitter, well, now I'm going to need to have a barrier integrated in there in order to meet the intrinsically safe transmitters requirements. Now, it's worth noting there that Precision Digital will soon be launching a barrier that fits in the bottom of these explosion-proof boxes. So we'll save you the need to do yet another installation step. You'll be able to have your explosion-proof product with the integrated barrier to go off to your transmitter and be powered by the Protex Max. So essentially one product, combine it with your transmitter, your solution is done. But you still need to be aware of the fact that, well, this is part of the intrinsically safe approval, therefore I need to make sure I get the barrier. This product is part of the explosion-proof approval, therefore I need my seals. So it's important to understand those protection concepts and what they're trying to do. Luckily, the equipment's going to come with all of the information you need to know. So when you get the instruction manual for one of these PD8 Protex Max units, it will tell you that you need to put seals within, let's say, 16 inches of the conduit entry point. It will be there. It will explain it to you. That's what all of these products have in their manuals under all of that hazardous area information. It's worth taking a look at when you do the installation. We talked a little about Nema earlier. It came with one of the questions. Nema ratings and IP codes, IP being more of a European standard, are really not a hazardous area approval per se. They're on hazardous area products, but they're not limited to hazardous area products. They're in safe area equipment as well. And they really relate to ingress protection schemes. In other words, how are you going to keep out material? There's a whole suite of different Nema approvals. The two that you probably see most often are Nema 4 and Nema 4X. Nema 4 is an indoor-outdoor protection that essentially says that it prevents against falling objects, falling dirt, blown dust, etc., ice, and hose-directed water. Nema 4X has all of the standard Nema 4 protections, but it also adds a level of corrosion resistance. So for example, if you have a plastic sealed box, that's probably going to be a Nema 4X box. It's good to go outdoors. It's going to be weather tight. It's not going to let dust in. But it's also corrosion resistant because it's plastic. If you have a steel box that isn't painted, well, now you're going to have just a Nema 4 product because salt water or just exposure to the elements is going to start potentially rusting off components of that. And so it's not a fully corrosion resistant product. It's worth noting that Nema ratings are a self-declaration. That means that while there is an organization that publishes the Nema standards, manufacturers self-declare that this product is a Nema 4X product. Now, hopefully, like Precision Digital does, they send this out to be verified by third-party testing agencies, but it is not a requirement of the standard. And while this testing is done by the hazardous area testing agency, so for example, FM will want to test to make sure the product is NEMA 4 before they say it's NEMA 4. There are plenty out there that say NEMA 4 that are not tested by FM at all, that are just safe area products. Some of you may also have seen something called Type 4X, and that is essentially UL's version of NEMA 4X. That is UL telling you, we have tested this product, we have decided it is NEMA 4X essentially, but we're going to put Type 4X on there to show you that it's a UL tested and approved environmental code. You saw earlier what the different hazardous area agencies you're likely to see in the US, that there are a couple of different versions of many of those marks. And so here's some examples of what you might see out there. You have to be prepared to see variants of these approvals and know that there's reasons why all of these changes are made. Sometimes they matter to you, sometimes they don't. So for example, look at the row here on the left with FM. Well, you've got FM approved. That's their standard mark. So this is just to let you know that it's an FM approved product. You're good to use it in the United States, facilities that take FM approval. Then you've got FM without the approved. Means the same thing as the above. Sometimes just due to printing requirements on products or space, you can't fit the approved, and so you don't have to put it. Versus FM that has the C and the US on there, which is letting you know that it's FM approving it to a Canadian standard and to the US standard. So in that case, that change is actually relevant. And you see that throughout the different marks. So for example, here's your standard CSA logo. Or you might see it without the registered trademark just because someone can't print that on their label. It's too small, or the mark itself is too small. Or maybe they're molding that into plastic and that little R isn't gonna work. But then you add a C and a US on there, and that lets you know, okay, those actually matter. When you start seeing things like C and US, now you're talking countries and various approvals. That's really what you wanna look for. So it really doesn't matter that if you have ATEX or ATEX with the actual word ATEX under it, but it makes a big difference if you've got UL listed versus CUL US or just CUL, because now those C's and those US's let you know you're talking countries and you're talking the different standards accepted in those countries. UL is also starting to move towards a new looking mark, and I'd love to talk to you more about that, but I'm certainly not an expert on it, but it seems like what they're trying to do is combine a lot of different approvals into one mark, and so it'll be interesting to see how that gets rolled out, but you may start to see it, so I figured I'd add it in here. If you see a mark that isn't on here, you do yourself a favor if you go and research it a little bit. Use Google. It's a handy resource. So for example, you may see a UL mark, but it's going to look like a U with a backwards R on there. Well, that's a UL recognized component. That is a different item than seeing something that's fully UL listed. And so if you find yourself working with equipment like that, look it up, find out what it's approved for. UL, you can go on their website, you can type in the file number, and it'll tell you all about that product, where you can use it, and what good it is. So if you see things you're not familiar with, don't take them for granted. Do a little research, call up your Gilson sales guy, talk to people about what it might mean. And when all of that is said and done, when all of those things have been determined by the agencies and they start giving you marks, then you get a label that looks like this, which is a whole bunch of alphabet soup that will hopefully mean a little bit more to you when we're done here today. And so I wanted to break it down a little bit so you can find what matters to you when you're looking at a label like this. This is an actual label from one of those PD8 explosion-proof products that we saw earlier, those Protex Maxes. And the whole top part of this label is really just about who the manufacturer is, where we're located, things that the agencies require us to put on there, model numbers and serial numbers. You've got the power requirements on there. That's pretty straightforward. Jumping to the bottom, you've got agency required warnings, things that they're going to tell the manufacturer they have to put on there that you want to know. So I would think it would be obvious, but you can't open when an explosive atmosphere is present. This is an explosion-proof product, remember? You could unscrew that lid and, well, you just destroyed your protection method. you've got to have those conduit seals we looked at within 18 inches of the enclosure. Talking about temperatures, wiring the compartment may reach 90 degrees and ambient of 65. So you got to make sure you use cables that are appropriate. And CSA wants to make sure you derive power from a Class 2 power supply. All fairly straightforward. Then in the middle of the label, you've got all the other information that we talked about. And hopefully when you look at a product like this, the manufacturer's grouped it up by symbol so you can sort of look to the approvals that you want. So for example, if we were interested in FM, I could look here on the left and I can see that, well, all the information over here is for European approvals. And I know that because here's my ATEX mark. Here's my CE mark, which again, all has to do with Europe. Other marks really are just European related things. And so that is all just for ATEX approvals. And we can break that down and go through it, but you can see it on the screen and get a sense of what it means as far as the groups and zones, et cetera, that are appropriate for ATEX. Over on the right, you've got your FM and your CSA. So now we know we're getting close. These are the kinds of approvals that we're most interested in here if FM is our concern. If we know we want to go get an FM explosion-proof product. So now I've got enclosure type 4X and IP66. All right, so there's that type 4X I was talking about. So I know that we're talking about a Nema 4X product that has been tested to be Nema 4X. They also put the IP rating on there. I didn't focus too much on IP, though just a quick note about that. IP66, IP65, one of the common questions we get is it the equivalent of Nema 4X? Unfortunately, like many slightly different standards, they're not exactly equivalent. So if you have a requirement for Nema 4, will a IP65 or an IP66 product do it? Maybe. It depends on what they want the Nema 4 or Nema 4X requirement for. IP65, IP66 have nothing to do with corrosion resistance, for example, like Nema 4X does. IP65, from just my personal experience, having watched some of the testing, I don't think IP65 is quite as good as Nema 4, but IP66 might actually be a little better. So they're not exact, but they are related. So anyways, I know if I'm looking for FM, I'm probably interested in something that's Nema 4 or Nema 4X. And there we are. I know I'm a type 4X, so I've got that covered. Then you've got your different classes and divisions. Now, this product is approved for multiple classes and divisions. So I'm good for class 1, 2, or 3. So I know that I'm good for gases, dusts, or particles. And I know that I'm good for division 1, which is my worst case scenario, right? That's where I'm going to have flame present on a regular basis. It's expected that I'm going to have hazardous material. They've tested it for 2 different temperature codes. I've got T5 and T6 on there, which translate into the fact that I have multiple different operating temperature ranges. So you'll see there I've got my T6 temperature range where I'm good all the way up to 60 degrees, but then I've got my T5 temperature range where I'm good up to 65. And so oftentimes a spec for this material will say it's got to be a T5 product, for example. Well, if I know that it's got to be a T5 code, then I know I'm good up to 65 degrees C ambient environment temperature. And then I've got my groups, which are B, C, D, E, F, G. So if I know that I'm looking for a gas that falls under my C group, well, I'm good for class 1, division 1, so I'm good for that gas to be present. I know that if it's a gas that's in the C group, I've got that group covered. And I've got my FM mark on there, so I know that I've got FM approval for that. If I want to be sure about that, I can actually go and verify. I've got the FM certificate number on there. Which means I can go look up this certificate either with FM or I can request it from the company and say, okay, I want to see the certificate that FM issued that actually shows me this approval and verify that it's actually correct. Now, you'll also notice that FM does have the zone information on there. So if you were a company that was more interested in zones, more likely you might be looking for ATEX or IECX, but let's say you wanted zones and you wanted FM zones, we have it approved with FM zones, and so you see some of that information on there. And that's the kind of rating where you see class 1, zone 1, and then you see a little extra information on there. like this AEX D2CGB, which is a breakdown of the enclosure, or the protection method rather, combined with the zones, how it gets that protection method accomplished, and the types of gases and dusts. You'll see that all translated down here, where if I wanted zones, we've got all that information on the label as well. So one of the reasons a label like this looks like such a mess is because you've got 4 different agency approvals on here. You've got ATEX and IEC, you've got FM and CSA, you've got to cover zones and divisions, you've got to cover all your different zones, or all your different divisions, which means you've got to have all your different groups. And it's a lot of information to try to get across to someone, some of which may matter to you, some of which may not. But that's why when you look at it, there's so much there. And the key to really understanding your products is to be able to look at a label like this, find the parts that matter to you, and know what they're trying to get across. So hopefully seeing a breakdown like this makes it a little bit more manageable when you try to look at that product approval, or even when they're listed on a specification sheet, and digest it a little bit easier. Might leave you wondering, all right, what kind of equipment or protection method do I need? We talked a lot about that during this webinar so far. And so my personal advice is usually you're going to be looking at either intrinsically safe or non-incendive equipment or explosion proof. Certainly there are purge panels and such out there, but if you're talking about a standalone piece of equipment, those are the protection methods you're likely to see. Your intrinsically safe or non-incendive equipment, it's got some pluses and minuses, as one might expect. So these are low power devices. They're designed not to have enough power in them to cause an ignition, which means limits what the devices are capable of. So you're going to see LCD displays, which may be backlit. The ones from Precision Digital will be, but oftentimes they're not. And that low power electronics limits the kind of outputs and control options you've got. So you might have transistor outputs, which you could send to a PLC, but you're not going to use to turn on a piece of equipment like an external relay. We do have products with some solid state relays that we designed ourselves into them and got approval on. So in something like this panel meter that you see on the left there, you can actually get solid state relays to be able to do things like pump control on an approved device, but that's pretty rare. You usually won't see that. They will often be loop powered. If they're not loop powered, they'll at best be low voltage DC powered. That's fine if you've got enough power in enough voltage drop in your loop to run these devices. They tend to be lower cost because you're not talking about an aluminum housing around these, and because they have limited electronics capabilities, they just tend to be lower cost. And you can get them as non-incendive, which is a nice factor because it avoids the barrier requirements for Div 2 areas. An intrinsically safe product is designed to work with a barrier. So something that is solely intrinsically safe is going to need that barrier even in a Div 2 area, versus a properly approved non-incendive device that should be good for the Div 2 area without a barrier. So something to keep in mind. Now your explosion-proof devices, those are where you're going to find your bright LEDs, your really bright backlights. They're going to have really no power requirements, sort of the most basics of what you need to worry about for heat rise. So you can fit all kinds of features into these. That's how you're going to get your mechanical relays, your powered 4 to 20 milliamp outputs. If you want Modbus, you're going to find it on explosion-proof devices. Precision Digitals will offer 24-volt power supplies, both to run your 4 to 20 milliamp outputs, but also to run your transmitters. If you'd like something that's line powered, so let's say I have 120 volts coming into my area, I don't have access to 24 volts easily. Well, great, you can get a line powered high voltage device. It'll offer 24 volt output as part of it. You can use that to power up your transmitter. And a lot of people just like working with explosion-proof equipment because of its inherent ruggedness. That could be a choice they're making because they want to have really rugged, solid equipment in their hazardous area, or sometimes, to be quite honest, we see people buying it just because they want that rugged housing, even when it's a safe area. But you can see where, a sealed field mount box in an intrinsically safe or non-incendive item certainly works, but it's a plastic housing. It's not going to be as rugged as something in a large explosion-proof housing. I mean, the thing is designed to contain an explosion. it's going to take a beating from the people in your facility. Some other things to consider when you're choosing one over the other. Confirm you have the approvals you need for your class, division, group, temperature, etc. There are plenty of products out there that, unlike the one we looked at from Precision Digital, don't have all the worldwide approval marks on them. You might not get all those options. You might have equipment that only has ATEX. Well, geez, is that going to work for you? That's a question you should decide before you commit to that product. Oftentimes, facilities have preferred protection methods. You may know which one you like. You may say, you know, we only do explosion proof, or we only do intrinsically safe, or non-incendive, for example. So know that in advance. You know, don't go looking at something that's explosion proof if you know that you're going to want to install an IS device instead. Know what marks are acceptable for you. Is a CSA US approval sufficient for you or not? If you get a product that's manufactured in Canada, maybe your only choice. You know, is an ATEX approval okay for you? Well, maybe not. Consider your input and output requirements that you're going to need for the rest of your system. You know, I'm talking about sort of display and control equipment here, but maybe you know you're going to need certain pumps or certain valves that it needs to interact with the PLC, and you may find out that you have I/O requirements that require you to use something explosion proof in order to get the kind of outputs you need. Know what your mounting and location preference are. You know, do you want something in a field mount box? Would that be more convenient? Do you want it somewhere where you have a really rugged enclosure? Is there a space limitation? Those are all good things to know, because it's gonna, the minute you make a protection method decision, it's going to limit your sizes, your methods of mounting, etc. And know what you and the people at your plant are good at. You know, stick with technologies if you can that you're familiar with how to work with. This is, after all, a safety choice. And so don't go trying things that are too new that you are not comfortable with. You know, always be sure that you're doing it the correct way, because you just can't afford mistakes with this stuff. If you have questions, find somebody to ask. Don't make assumptions with this kind of equipment. Once you make that decision, what might that look like? You know, what is it? What are some real world examples? So here you'll see 3 different versions of, just for a simple application example, a tank level display I might get to choose from. On my left, I've got my intrinsically safe and non-incendive panel meter, the PD6600. Well, the price is certainly great, right? It starts at $329. I'm glad to see that. But I've limited myself to a loop-powered device. It's got a low voltage drop, which is nice, but I know I'm talking an LCD and a loop-powered device. I've got ATEX, ICX, UL, and CUL listings, which is going to be good. As long as I'm not required to stick with FM, I've got UL and CUL on here. Most likely, you know, I'm going to need UL in this case, and so that's fine. You'll note I don't have FM though. I've got a Nema 4X IP65 front, so I've got to consider how I'm going to mount this panel meter if I go that road. And while I've got free PC-based programming software through a USB port on the side, it's a loop-powered device, so it doesn't have access to RS5 and Modbus. So if I was hoping to do some Modbus communication, I can't do that here. And mostly I'm limited to open collector outputs or passive 4 to 20 outs, though I do have solid-state relays available on this particular unit from Precision Digital. If I wanted something explosion-proof, I've got a very close equivalent to that panel meter available. Now we're putting it inside of a modern, sleek, rugged, explosion-proof housing. So you'll see that price goes up pretty significantly. But now I've got those explosion-proof approvals, right? I'm an explosion-proof IP68 Nema 4X enclosure in there. That also gets me access to that FM approval I needed. And if I know my application is going to require a lot of capability, well, then I'm going to go with the PD8 6000 meter. Now I can get it line powered, so if all I have is high voltage, I'm fine. I can power it off 120 AC. I've got sunlight readable LEDs. I've got my FM approval on there. And if I know I'm going to be using it to run all kinds of equipment, now I can get up to 4 Form C relays. I can get isolated power supplies. I can get powered 4 to 20 milliamp outputs. I can get digital I/O available for it. It comes with Modbus if that was something I wanted to connect to. I've still got my programming software, but the price is going to be higher. And so it's a nice example to look at and consider what impact all those choices will have on what kind of equipment you choose. What kind of marks you want, what the area requirements are, what the application requirements are, is going to make sure you help get the right device when you're trying to specify this equipment. So with that, I know we're reaching the limit on our time here. I'm happy to take any other questions we may have.
Yep, we got a few here. First one is, could you expound a bit on CSA/UL agreements and how they relate to reciprocity in the US ratings per NEC?
Sure. So CSA and UL have essentially signed agreements with each other that allow them to share testing information and compare their standards so that UL is testing to CSA standards and CSA is testing to UL standards when they're getting sort of into each other's traditional backyard. You know, traditionally UL was US and CSA was Canada. So specifically, I guess what you're asking is can I use a product with a CSA US mark in somewhere that most likely you're used to code saying you've got to use something with a UL mark? And unfortunately, I can't just say something as simple as yes, you can go ahead and do that. And the reason why is because the standards that a CUL product is going to be marked with, a UL product with Canadian approval, so it's going to say CUL on it. That product is going to likely have to do with, wait, I'm sorry, let me turn that around. A US CSA product is what you're probably talking about, which is a CSA marked product with US approvals on it. It's probably going to have to do with more modern, standardized, harmonized approvals like zones, etc. And so you are unfortunately still going to have to do some research to see if that's acceptable for you in your facility with your inspectors with your company. You can't. I don't think you just want to jump to the conclusion that okay, well, this product that had UL on it had such and such a class division on there. Now I'm just going to bring in this product that has CSA US on it. I wouldn't jump immediately to that conclusion. I would do a little bit more first. It'd be great if I could tell you to do that, but I think you'd do yourself a favor to dig in a little bit with your local authorities, so to speak.
Second one I have here is, how does the proximity to a known venting point with natural gas affect the division classification? Are there set distances from these points where you can get to Div 2 from Div 1?
So there's no specific set distance set by the agencies. It is up to facilities essentially to determine and then get approved what areas are Div 1, Div 2 related to, you know, how close, for example, to a vent they are. There are standards out there that are published by all sorts of third parties that will recommend, well, this is how far you can be to, say, a vent, but a lot can come into play. Is this an outdoor, let's say it's a tank with a vent on it, is this an outdoor tank, an indoor tank? Are there special venting air handlers that will take that gas out of there? If not, well, now this whole area might be because I'm building up the gases. A lot can go into play there. It's not something as simple as, well, if I'm 5 feet, let's say, away from that vent, I know I'm good. The whole environment around that vent is going to determine that distance. And how you do that gets fairly complicated. If you want to connect with us after the webinar, I might be able to find some references to point you at. But it's not a simple determination like I can just say, well, 10 feet from the vent, you're good. Unfortunately, like a lot of things in the hazardous area world, it is more complicated than that.
Next one I have, will the exterior of the device indicate the IS barrier is contained within the device? I'm sorry.
So if you are referring to the reference I made earlier about Precision Digital's Protex Max and the fact that soon we'll be coming out with barriers that will be put in the back of that enclosure, no, the exterior of the product is just going to indicate the Protex Max information. The barrier itself is a separate product accessory, and so while it will have its own labels, and you could certainly get a stainless steel tag to put on there that would tell you that. It's not going to be purchased as a single package where the exterior of the box is going to contain that information. That sort of information is great for stainless steel tags. We offer those ourselves, so I've seen all sorts of information put on those in the past, and that is a nice piece of information to put on there. Well, I'll leave it at that. It's a nice piece of information to go on there. It's not, if it's something you want to mark on there, I'd suggest that you do something like a stainless steel tag versus just putting some kind of label on there, just so you have access to it. But the answer to your question essentially is no. They won't have the marking on the outside by default.
Okay, I'll ask the other customer question and then I'll ask the Gilson guys question.
Okay.
Customer asked, if a product is approved for Class 1 Div 1, does that mean it is acceptable for Class 1 Div 2 also?
In most cases, yes. You'll want to make sure that your local inspector, so to speak, or that your company has a policy on that. But generally, yes, you're going to be able to do that.
Okay, and the last two. The first one is, on a 2-wire device, if I use an IS barrier, does that meet Class 1 Div 1 requirements? And that also has a statement in there saying, explain that the transmitter must be IS, as some devices like a capacitor can store energy and thereby cause a spark. So the transmitter must also be IS certified, and one must look at the entity approvals of the barrier and the transmitter to be in compliance.
Sure. So the core question there, on a 2-wire device, if I use an IS barrier, does that meet Class 1 Div 1 requirements? And the answer there is not always. Certainly, if you do meet Class 1 Div 1 requirements, then you're probably going to be a 2-wire device, but not all 2-wire devices will meet. And what I mean by that is, first, you need to make sure that your 2-wire device, so let's say I have a 2-wire transmitter that I'm talking about here. I need to make sure that transmitter has a hazardous area approval of its own. Assuming that it does, and it's a 2-wire device, it's going to be a Class 1 Div 1 intrinsically safe transmitter. Along with that approval is going to come a set of entity parameters. In other words, it's going to tell the purchaser, it's going to tell you how much capacitance is in this product, how much inductance is in this product. Because remember that an intrinsically safe device is protected by limiting energy available to cause an explosion. So if you've got too much of that, that's a problem. You know, a capacitor's basically, if you add too much capacitance, then you're storing that energy. Then to get the signal through to the transmitter, you're going to have to go through a barrier. And what those entity parameters are used for is to compare the entity parameters of your transmitter to the entity parameters of your barrier to make sure that your barrier can handle the entity parameters of the transmitter. And so you're going to want to make sure that your barrier and your transmitter have compatible sets of entity parameters to work together.
And the last one is how to comply with non-incentive installations requirements for Div 2 areas.
So the high-level answer to that question is the Div 2 product's going to tell you how to comply with that. They're likely going to have a separate control document that will tell you anything you need to know about installing that. Most likely, if you're installing a Div 2 product in the Div 2 area, it's going to essentially be like wiring up any other 2-wire device. For example, Precision Digital has ones that you, as long as you correctly wire the thing, you don't have to go through a barrier because you're in a Div 2 area. It's assuming that for there to be explosive material present, you've already got a problem. And so it slightly relaxes the requirements that, say, an intrinsically safe product might have to face, like barriers. I think something really important to point out when you're talking about Div 2 is you want to make sure you have a non-incendive Div 2 approved product. Do not just take an intrinsically safe product, install it in the Div 2 area, and don't attach your barrier. You've got to make sure you have the appropriate approvals to do that.
And those are all the questions that we have. Yep.
Well, great. Thank you very much, everybody. I appreciate you all sticking with us. Hopefully you found it very informative. Let me personally thank Gilson for putting this together. we have a lot of information at Precision Digital we love to share with people, and it was very nice of Gilson to put that on. So thank you, everybody at Gilson, for putting